4K, less of a fisheye view to hopefully show you a little bit better in detail what I'm doing. Huge disclaimer, not a shop, not a mechanic. So I've got pictures of how everything was previously. These are new ACL bearings. This is the bottom part that goes in the block. These are the top parts that go onto the main caps. I'm gonna clean everything once more with brake cleaner, and then we go and continue do the same thing I did in a previous video with the Plastigauge. Update. I did everything as I did last time. These were my previous clearances in millimeters, about 0.015, and now they are super loose, where previously it was here in millimeters. It is now there. I've heard that it's better to have looser bearings than tighter bearings, but of course if the manual states that you would want to be like a little tighter, then I think I would prefer to have tighter results. But I'm gonna try and do this again, so I'll get back to you. As I want to take you guys through the whole experience, basically it's almost nighttime now. I removed the crank 2 times, I remeasured 3 to 4 times, but yet all measurements always come back to the same thing, which is logical because these are race series bearings, so they are supposed to have a bit of a looser tolerance. But if you look at the BMW manual, they are just out of spec, which for some forums I read is good for performance, and then other sources say it's not good. So in inches it is 0.03. For most videos I look online I find 0.02. It's quite a difference. So if you look at this, this is definitely closer to 0.03 than it is to 0.025. So is this 3,000s? Probably. I'm not sure, I don't work in inches, but this is the same spec. This also is 3,000s. This also looks to be exactly that. This one might even measure a tad bit smaller than that. And this one is almost that, and then this one measures also that. So it's 0.03, which I think is 3,000s, and I've remeasured this over 3 hours or so. I took my time, tried everything, so I'm not sure yet what to do. I won't bolt this down. I'm just gonna quit for today and have a good look online. It's update time. I wanted to make sure that the crankshaft wasn't grounded, so I checked it. Everything is stock, everything checks out. The same neighbor that lent me the huge torque wrench lent me 2 micrometers, one for the crankshaft journals and one for the conrod journals. I had to do it like 2 or 3 times because I just wanted to be completely sure. There's 7, it's all 59.98 or 97.5, and I'm well within spec. So this is a regular crankshaft. I wanted to continue today, but I want to be sure that the mains are good and everything is here. Then I can put plastic over it before I start grinding and filing and doing that kind of stuff. So I also have this. These are ACL specs. They come back to product number 7M1532H, which is this. The minimal and maximal vertical oil clearance are supposed to be between 0.034 millimeters or 0.088 millimeters, and for me they came back to 0.076. so that's in between ACL's allowed clearances but still on the higher side. So yeah, I don't know how to continue from here, so I'm gonna think about this some more decisions to make, and I will get back to you guys and tell you exactly what I did. Also, I think it probably would have been better to say F it and not open the bottom end, because this is what I see now. These are the OEM bearings, and as you can see they are in okay condition. There's like a shinier layer to it, so it's going through, but there's no real damage. So I probably would have been good. I should have been negligent and just said fuck it and run it with stock bottom end, although it needed a resurface, so I don't see how that would have went. But yeah, if you're going to do this and you don't want to open the bottom end, you will probably be good. It's probably better to change them, but if you run into this whole ordeal, I don't know if it's worth the headache. We'll be right back, I guess. Alrighty, last weekend was Drift Masters. We went to Poland. I got sick, you probably can still hear it. But let's continue. Last time I stopped with the ACL bearings because the clearance wasn't right. Now we got standard Glyco bearings. So let's do this again. Whee! The Glyco ones that go into the block are in. We're quite some time further because I had a hard time with the thrust washer, so I hope this does not have to come out. It shouldn't if the clearance is alright, but yeah. So next step, crankshaft. I'm gonna clean it thoroughly, then lay it in, do the upper ones. So I've got Plastigauge 1, 2, 3, 4, 5, 6, 7 times. The bearings are in the caps. Again, same thing. Thrust bearing was super hard. For some reason I had to hammer it in. I did my best to not like damage anything, but I've seen people on YouTube trying to get these in, and I see hammers being used as well. So I'm sorry if I'm a little brutal. It's my engine, but should be good. Now we have to put in all the caps. The bolts are still somewhat oily, and the bottom of the heads as well, so I'm not gonna oil them up or anything. I'm just gonna hand tight everything first, and then 20 Newton meters, and then 50 degrees, and then hopefully the clearances turn out better than the ACL bearings. Okay, so I think I'm going to send it. Honestly, the ones that were in there were 005. Then the middle ones were a bit tighter until the last two. Then the ACL bearings were out of BMW spec completely. The first time I measured, the first 3 were on the upper end of the BMW spec, and then this time around the 1, 2, 3, 4, 5 first ones are good, and then the last 2 ones are on the looser side. So this almost comes to this, where the last 2 are a little bit looser, so I think it is fine. And then also I measured the crank, and from what I can see here, it is 98, 99, 99, 98 and a half, or 98, and then the last 2 are also on the looser side compared to that. So that means that it is normal that I measure a larger clearance at the end. Of course, it would be nice if they were all within spec and 005, which means 2 thou, but yeah, I don't think it makes much sense to order another set of OEM ones, because that would be then the 3rd pair, and I think I'm going to see the same thing. So you can see in inches, this is 2 thou, also very close to 2 thou. Same thing goes here, around 2 thou, maybe a little bit tinier than 2 thou. And then here, as you can see, I slide from left to right, and then here on the 2.5 thou, it is that. So last 2 ones are on the larger side. They were previously with the OEM bearings as well. With the ACL, they were all out of spec, so I don't think running ACL makes sense here. I thought about like messing around with the halves of the bearings, but it doesn't work for this because this is the thrust bearing, so this one will stay as is. I could potentially take the biggest one and move the cap to there and see if there's any difference, but honestly, if the crank journal here measures less than here, then makes sense that there's gonna be more clearance. I think I'm calling it, and probably just gonna send it. There's people that actually look for larger clearances than OEM spec, just so there's a thicker oil film so you can rev higher and have less issues with the bearings. So I think it is better with these ones than the ACL ones. It is what it is. I'm just gonna send it. So we're undoing all this, taking everything out, cleaning it one last time, and then I'm going to be using some assembly lube the bearings, lube the crankshaft, and then torque it down with new main bolts. Cleaning the crankshaft one last time. I don't think it is seated properly. Oh, now it is. Okay. Now we're spinning. Yep. Okay, let's continue. Very stressful, to be honest. Let's go. Old bolts, not useful anymore. So we need to clean these one last time. That's one of them. So I'll put assembly lube on the top halves, and then I have the new bolts. I need to oil them like a tad bit here, and on the threads just the tiniest bit. Let's continue. This is number 2. Two bolts, a little bit of oil. So the threads need some oil, and then these caps also need some oil so they don't go in dry. These are torque to yield, so let's do that for all of them. And there we go. So now clean my hands, do all these hand tight, and then do the sequence. Okay, let's get it to 20. Okay, that's 20. Let's see if it spins. Still does. Now let's use the dodgy tool to get it up to 50. Start with the center first. I'd like it to be blocked not only magnetically but also by this. So, and let's bring it up to 50. 50. Next up. That's 50. That's 50. So in good old GoPro fashion, it overheated. I torqued everything down with the assembly loop. The crank spins freely. It goes smoothly is what I want to say. So next up would be thrust washer clearance. You have like a dial for that. I do not have that. I think my neighbor has one, but I don't think he's home and I don't want to bother him all the time. So what I'm going to do is measure it with a feeler gauge. So in between the thrust bearing and the crank. So the tiniest one I have is 0.05 millimeters. I don't know what the spec is with these. What I'm going to do is pry the crank towards me. I would be able to put something in between this washer here. Okay, so that goes in freely. You can see the assembly loop popping up, and you can also see it on here. So 0.05 fits. Let's maybe try it the opposite way. It does go in there. It has a hard time going in that way though. So I think that's the best I can do for now. We are back for some more work on the engine. It's next weekend, Saturday. I had to buy stuff from Amazon, so I thought why not buy this. It's zeroed out now. It's squared up, or at least almost squared up, so now we can do the same thing but have a better reading. So to the one side it's zeroed out, or 0.01 millimeter, and then when bringing it back it moves about 0.1 millimeter in total, because this is 0.09, so that's 0.1 millimeter of play. So apparently this is good. My good friend ChatGPT tells me it could be minimal 0.06, which was what I measured with the feeler gauge, but I knew it wasn't too accurate. Maximum is 0.26, so we're perfectly in between, even on the smaller side. So sweet spot. Perfect.